You're listening to The Interactome, a podcast by a group of young researchers who want to connect you to the world of science by sharing their stories and perspectives. Just in case their bosses are listening, they want to remind you that the opinions expressed here are their own. They also want to remind you not to take anything they say as medical or professional advice, as they are not doctors. Not yet, anyway. Stay tuned about that. And, without further ado, welcome to the Interactome.
Hello, everyone, and welcome back to the Interactome. This is Natalie. It's been a little while since I've been on an episode, so I'm really excited to be here. It's top of the month of January. We're recording this, so Happy New Year. I don't know when you're going to hear this, so maybe that's not great to say, but alas. I'm here with my co-host, Sarah, and she is going to just say hi to the folks and introduce our guest today.
Hey everyone. So, like Natalie said, I'm Sarah. I have one of my really good friends on the podcast today, and she's going to be talking about her journey throughout really her life as well as college and the work she's doing right now. Her name is Emily, and we met at NASA during an internship last summer. She's fantastic. And so I will let her tell you a little more about herself. So Emily, without further ado, take it away.
Hi, hello. Yeah, Sarah's right. My name is Emily. I work for Texas A&M as a full-time research engineer. And yeah, I met Sarah not this last summer, but the summer before now, which is kind of hard to believe that it's been that long. We were both interning at NASA, and we were actually neighbors in the same dorm. And we got along really well. There's kind of a funny story that goes along with that, but I think at some point we'll probably have that conversation, right, Sarah?
Yes, we can do that. That's awesome. So yeah, we can, I mean, if you want, we can just jump right into NASA because I think that's really where like our story begins and is really going to be the focus of this episode is your work in the space industry. So, at that time, summer 2023, what actually ended up bringing you to NASA? How did you end up getting there? Because I feel like everyone comes to NASA in a slightly different way.
Yeah, so the way that I got to NASA, it was kind of unconventional. So I had a professor that semester that I kind of just got by chance. Her name was Dr. Curie Gregg, and I was taking her class because one of my other classes had for whatever reason, the professor had changed when some of the class periods were going to be. So it like interacted with one of my other exam periods. So it just kind of got shoved off in my schedule. And I had to last minute find another elective credit to take so I could graduate. And I had gone to my advisor, and my advisor, me and her kind of knew each other somewhat well. And she knew that I really admired this one professor in my department. Dr. Curie Gregg, if you don't know, was an astronaut, and I was really excited about it. So she said, "Oh, there just so happens to be like one more opening in this class. If you want to take it, I can just put it on your schedule, and you can see how you feel about it." So I went ahead and took it.
And can I ask what she taught?
Yeah, so the class was called Human. I think, forgive me, this was a year and a half ago, or maybe more now. I think it was Human Error and Resilience. So the class was a human factors class that was
I know
essentially,
something about that.
yeah.
Actually, I'm just realizing now that all three of us have interned for NASA, haven't we?
That's awesome. Yeah, but so it was, I think it was human health and resilience. But essentially the concept of the class was it's kind of encapsulating all the different ways that accidents can happen. And it kind of goes through like maybe from like an organizational level or even like a governmental level, and then it goes all the way down into like a person by person level of what sort of things go into accidents, and trying to figure out what like the root cause is, what actually happened, how we can prevent them, what's the psychology that goes into like accidents and accident prevention. And I really, really enjoyed that class a lot more than I expected to whenever I, just kind of hopped into it. And after class one day, and this, keep in mind, this was so early, and I don't even know like how I had, I guess, the audacity to even do this. I was so starstruck by her, but after class one day, I convinced myself like I need to go talk to her. I don't even know what I'm going to talk to her about. I just need to talk to her. And I went over, and the actual words that came out of my mouth, and I hadn't prepared it, I just said it, was, when I grow up, I want to be just like you. How can I do that? And I don't know why I said that.
No, but that's adorable though. If somebody said that to me, I'd be like, I've got a wing and you're under it.
Yeah. Well, so I just want to also set the scene for a lot of y'all. Keep in mind that this lady is maybe 5'2", but she walks and talks like she is 7 foot tall, and she's so incredibly intimidating. Everyone who speaks to her is intimidated, but she is just awesome. So one of the strongest ladies I've ever met, and she's intimidating for a reason, and just very, very cutthroat, very to the point. So for me to have done that, I don't understand why, but she I don't know that she really knew me all that well at that point, but that just, I feel like, makes me feel so much more grateful that she had a connection at the contractor that I ended up doing my internship with, and the career fair had just happened to be the next week. So she said, give me your name and I will give you the name of this person that works at this company. I want you to send him an email, and when the career fair comes around, please send me a Teams message or something like that, and I'll get you guys linked up. So I guess for context, and I guess we just kind of jumped into this, but I graduated from Texas A&M with a degree in industrial and systems engineering, which is kind of a broad engineering field. It's kind of the general engineering of engineering. You do a little bit of everything, but it's up to you to specialize. But the way that Texas A&M career fairs work is there's these booths, and usually they'll have a list of majors that are acceptable to approach those booths. So they'll say like, oh, we're looking for a bachelor's, master's, or a PhD level intern, or we're looking for full-time, and we're looking for these specific degrees. So the booth that I went and approached, because my professor told me to approach them, they only had aerospace. So if I had not been recommended to them, I would not have been able, or not been able to, but it really wasn't recommended that I go and speak with these people. So I went to the booth and kind of had a short chat with the people, and I think they seemed a little I think at first they seemed a little disinterested because I had mentioned my major, but I mentioned Dr. Curie Gregg's name and had mentioned that she recommended that I come and talk to them, and that I maybe come and do an internship with them. And it was just over immediately. They seemed so excited about it, and oh yeah, we'll reach out to her and we'll talk to her. I mean, they thought the world of her. And I think I didn't even do an interview. I mean, they just hired me basically on the spot. And I did not know this at the time, but the spot that I ended up getting for that internship, I had competed with over like 200 other applicants. And just because Dr. Curie Gregg had really gone out on a limb and, vouched for me, it really helped get me through the door so that I could have additional conversations with these people who are hiring, and they could, say, okay, she's a pretty good fit, and she has a really good recommendation, and we can go ahead and put her through. But I was so, so grateful for her.
I think, first of all, I think that's a fantastic story to tell, because we have that happen, I think, so regularly in our lives. Like, I truly feel like that level of networking, or even just friendship with people that you strike naturally, right? Like, I think there's the type of networking where it doesn't come from necessarily a genuine place, But like when it comes from that genuine place, it is that much more impactful, I think, and meaningful to both of you, whoever like, the mentee is and the mentor.
And I
So,
think too,
yeah.
like going off of that point, yeah, like there's good networking, bad networking. Like Emily, you didn't go up to her to say like, okay, can you get me a job? You went up and been
Right.
like, this, like I know what I want. It's this career path. Like, tell me where and what I need to work towards to get there. And I think that that's just so different than being like, can you help me get an internship? It just, I think if
Right.
you had approached it that way, like she would not have gone out on a limb. So
I don't think
honestly,
so either.
yeah.
I totally agree with you. And I think, that really wasn't the intention when I reached out to her. I looked up to her so much. And I was honestly just being super dorky. And I really just genuinely wanted to know, like, not necessarily what's your secret, but like, do you have any advice for, like, I would love to glean just anything from you. And I've just found in my life as I've gotten older that it's so important. If you walk into a room and you're the most interesting person there, then you're in the wrong room. Or if you're in a room and you're the smartest person there, you're in the wrong room. You need to genuinely be impressed by people and be, feel that you can learn something from people. And if you very rarely or never meet somebody that you feel like you can learn something from, I think you kind of need to change your perspective.
So I'd love to hear, and I'm sure after that serendipitous story, I think would love to hear more about what this internship was and what you focused on.
Right. So, I worked for a contractor, in the Safety and Mission Assurance Directorate over at NASA. So I was spending a lot of time using models such as Cream, and THERP. So these are models that were developed a long time ago, based off of old Russian and European, nuclear power plant data. So essentially, a group of people went and found out how often people who were working at these nuclear power plants were having like human failures. And over, years of collecting this data, they generated percentages of how likely it is like how likely it is for a human being to make certain mistakes. So something that NASA tends to do is they take these percentages and they adapt them for spaceflight because they're so
Mm.
similar. So a lot of what we were doing was we were trying to develop and a probability of failure for certain missions and for certain aspects of missions. So what I ended up doing was I was trying to create a tool to make some of these calculations faster, essentially. So I was taking like the calculations that you would normally be doing and I was trying to standardize them into kind of like a program that would be like a tool to help. Just because keep in mind a lot of the failure modes are, well, I say there's just a lot. There's a lot of failure modes. And
And what is, if you don't mind me asking, like a failure mode? Like, what
right.
does that mean?
So that can be broken up into a couple of different things. So there's two different conditions. One is considered loss of crew, and then there's one that's considered loss of mission. So a loss of crew always implies a loss of mission, but a loss of mission does not always imply a
Hmm.
loss of crew. Um, so you can have a failure where, let's say, for example, you are sending a mission up to orbit the Earth for 6 days, and your main mission is to try and grow a fast growing plant or something in this low Earth orbit, and you're sending the crew back. Your loss of mission could be, maybe there was a light bulb that was very important for the crew to use to actually grow these plants. And for whatever reason, the light bulbs did not make it up to low Earth orbit or something similar. They're unusable, and the mission cannot be completed. That's a loss of mission, and that's technically a failure mode and something that we can calculate for. But a loss of crew would be like obviously a crew either passes away, but it's also if a crew member is so harmed that they are in a condition where they cannot continue the mission as well. And so that's an automatic loss of mission and loss of crew. So you are calculating all of the different things that could occur that could lead to either one of those situations. We can kind of start going into like what like some of the things that happened that summer. Like I'd love to talk a little bit more about like how I got to know Sarah and like how we met.
Sure.
Yeah.
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 So I remember, so I actually I moved into a dorm. That was not my first choice living in Houston. But I ended up working out I ended up working out living at I don't remember what it's called. I think it was called Hunter Hall.
Yep.
Yeah, so this was University of Houston Clear Lake, and after living in an apartment for several years, I was mortified to move into this like little dorm room. But my grandparents, who I live with when I'm not at my apartment, or who I was living with when I wasn't at my apartment, they kind of dropped me off with my little suitcase or whatever, and my first car that I had never had any experience driving except now for the first time in Houston, which again was mortifying for both of us. And
Houston's all highway, from what I've heard.
all highway, and that's how I had to learn how to drive, and it was so scary. It was horrible.
That's terrifying,
Yeah.
actually.
I actually didn't know that, by the way.
Yeah,
That's something I didn't know.
Yeah, I did not have a car until the summer after my senior year of college when I was doing this internship. And I learned how to drive in Houston on the highways, and that was so scary.
And now
Good
you can
training.
drive literally anywhere.
Yeah,
Yeah.
oh yeah, I'm so confident. I drive like I grew up in Houston because that's where I started driving. So I'm not that aggressive, but but I moved into this little dorm room, and it was just a little one by one, but I did not realize that at the time I was like neighbors with Sarah. So the university dorm was going through this process where they were trying to update some of the generators. So it just worked out that while they were doing these updates, they were having some trouble with them. I don't know what the trouble was, but they just didn't turn back on, and it like zapped the entire power grid for like the building. So the power was just completely off. And we got back from work one day, and keep in mind I didn't know Sarah at this point still. And a lot of us were just sitting in the lobby because we weren't allowed to go up to our rooms. And it started to get dark. So
And by the way, sorry, for context, this is like the first week of the internship.
Oh yeah,
this is like
the first week.
We just moved in, and then we come home, and like it's just no electricity.
Yeah, no electricity. We're not allowed to go to our rooms. We have to
During a Houston summer. Like,
Yes.
literally give me a break.
Yes. And so the sun starts to go down, and these, the people that work for the dorm, they come out and they're like, "Hey guys," and they're super awkward because of course this is, kind of an awkward thing. You guys aren't allowed to be in the building if the power's out and the sun is down, so we don't really know where you're gonna have to go, but you can't stay here. Basically, they kicked us out. Fully kicked us out. And I was like,
I don't
what?
care where you go, but you can't stay
hold on,
here.
though. Wait, but to their credit, though, they did put us up in a hotel.
Yeah,
right?
Later. Hours later. So
that was it later?
Yeah, I did.
They're like, I guess we should give them housing.
Yeah, so I did not stick around long enough to find out, because they did that hours later, and I didn't get the hotel because I was like, all right, peace out. Like, you don't have to tell me twice, I'm leaving.
Wait, where did you go?
So I actually had a really good friend who worked with me, whose aunt also worked at the company that we were both interning at. So I stayed with her.
Okay.
She had a nice house nearby, and they put me up for the night, and it was awesome. They were super sweet. But yeah, so me and Sarah actually met while we were both sitting in the like lounge downstairs. And we were just sitting next to each other and struck up a conversation, and we just ended up having like a really good, really long conversation about a couple of different things. But we were kind of, talking about deep stuff about our internship. We talked a little bit about the faith. But I just remember we found out we kind of lived, we were close to each other in the dorm hallway, and at that point I don't remember us being like immediately like amazing best friends, but I just remember being like, okay, this girl's pretty cool.
Yeah, I remember being like, wow, I really want to be friends with this girl.
Yeah.
Yeah.
So fast forward, I don't even know how long it was. It was not very long. We like,
One day later, the
yeah,
next morning, I wake up in the hotel that they had put us up in, which was actually quite a nice hotel. And I had decided that morning because my, yeah, like I woke up early that morning. I had decided to go skydiving that day because my mentor at NASA was like, take the Friday off. I think it must have been a flex Friday, which is a thing at NASA where um, you will put in extra hours of work earlier in the week for a period of time and enough to basically take a full day off. And so that kind of
yeah.
cycle repeats every 2 weeks, which
And
is,
just for context as well, the way that most NASA jobs and internships work is you log yourself as if you're doing hourly pay. So you'll say that I worked such and such amount of hours during a day, and I worked for this particular project. So you have to put like a code in. So that's kind of how that works. I know there's some jobs that are like, oh, cross your fingers, just promise me that you worked such and such hours during the day, but you actually have to log at NASA that you are working a certain amount of hours every day.
yeah. And so it depends what kind of internship you have. But anyway, that was much more eloquent than what I was saying. But so to sum it up, I basically decided to go skydiving that day. I had the day off. And then I won't get into too much detail, but the skydiving did not go nominally. And I ended up having to go to the hospital for a decent amount of time, like 1 or 2 weeks.
I did
And
not know you went skydiving, and that's why you went to the hospital.
yes,
Yeah.
this,
Yeah, and I
yeah,
remember her mentor, like I finally met her mentor like later while she was in the hospital, and they were talking about how what ended up happening was so incredibly rare and just very like straight, like it doesn't ever really happen to people during skydiving incidents, and I just remember that being like blowing my mind.
yeah, it was definitely something that doesn't, or at least it's not reported really in the literature at all. I think there's like 1 or 2 other cases that have been written up. Um, and everything's fine, like I'm fully healed. But it was just such a sort of like a lightning strike sort of experience. And that's really how Emily and I got close. I think we got close pretty quick, I think because of that.
Yeah.
I remember Emily came to visit me in the hospital. She brought all my important things. She spent time with me. I remember I remember so vividly the day that I got out of the hospital. She picked me up in the car. I was still in my hospital gown. And then I think we drove back to the dorm. I changed, and then we all went to HEB, which is the grocery store down here. And I was pushing around this like, because I had this weight restriction. I couldn't lift more than 10 pounds, or exert like 10 pounds of force. So I had the like sort of like the grocery cart that you can.
At the time, I was still using Snapchat a lot. And I would also like to say for context, I don't want to out myself or anything. I still use Snapchat. Yes, I'm 23 years old. I am the oldest of 3 younger siblings. So I am required to keep it until they grow out of it. All right. But I still get Snapchat memories sometimes from that summer. One of which of you driving that cart around in HEB.
Yeah, I get that too. I'm pulling this weird face. Maybe we'll post it somewhere. I don't know. But yeah, so that's how we really met. And I think since then it really, I mean, I think it set the precedent for our friendship, but it just was so nice to have someone around that summer that I felt really, really close to. We got really close really fast.
Yeah.
Um, and we do share, for good reason too. We share a lot of the same values, like our personalities just work. But that summer we talked probably, I mean, I think I talked more about space and just working in this sort of field more than I have with anyone else, like ever in my life. And it was just such a pivotal summer for me. So, yeah, I don't know if you have any other reflections on that summer that you'd want to share.
Yeah, so it was actually really nice to have met you because prior to that summer, I had not had a lot of very deep, meaningful female friendships in my life. And part of that, of course, was kind of going into like a male dominated field. You go into engineering, and at least where I was, there weren't a lot of girls in my classes, and that's just kind of the way that it works in a big school. There weren't a whole lot of girls, at least for the first like year or two, and then when I got into my major, things kind of started to mellow out and mix in a little bit better. But I never developed a very close friendship with a girl prior to meeting you and getting really, really close with you. And I just remember that entire summer, we were just like two peas in a pod. Like we weren't even working in the same directorate. We were nowhere close to each other, like on campus, really. Did we just happen to be neighbors? And we would like eat dinner together and we would go out together. I just remember we spent hours at that coffee place, Java Owl.
Mm-hmm.
And it was just so nice to have somebody that I felt like I could just, sit around with and confide in. And do you remember the night that you came over to my dorm and we sat on the floor and I like painted your nails? Like that was such a like small little like just girly thing, but it was just something that like healed me. It was just so nice to like have like a girlfriend that was just like, I don't know. It was really great, and I didn't realize how much I needed that at the time. I was going through some other personal things in my life, and just having somebody that I could be close to with that, like that, it was what I needed.
Yeah, no, it was honestly what I needed to, and I'm glad I could do that, like provide that for you, and I'm just so grateful that like we met each other at the time that we did. It was such a good summer. Anyway, we could reminisce about this for the whole episode.
Yeah, no, it
But
was
we should
great.
we should
We can move
probably
on.
we should probably talk about what you do now because I think our listeners would actually be really interested in that. And I also just want Natalie to get to know you more in this capacity as well. And what you do is so cool and so over my head.
Thank
And
you.
you talk about it so beautifully. So, do you want to tell I guess all our listeners um I guess how you got interested in what you're doing now and how your schooling eventually led you to where you are right now?
Yeah, so if you don't mind me like rambling, I guess a little bit, this is a little bit of a longer story how I got here. So this goes back to the professor I was talking about, Dr. Reg, and so part of the reason why I think that her and I ended up getting along so well later in the semester was because of a job that I was working at that time. So I worked a lot through college. It was just sort of what I needed to do, to feed myself. But I ended up working for the Texas A&M Cyclotron Institute. And for those of you that don't know, Texas A&M has a particle accelerator, and we actually have two of them. And it was again sort of right place, right time. I met my boss through an organization I was in at the time called SEDS, so Students for the Exploration and Development of Space. And I'm starting to kind of get deja vu, but I ended up cornering this guy after one of our meetings, and I said, I think I said something along the lines of, "I don't care if I have to mop the floors. Can I work for you?" And
Emily, I think you need to teach networking 101.
yeah.
Yeah.
I think that's what this is turning into.
Yeah. I'm beginning to realize that I might not have any shame.
Yes, you shouldn't have
It
any
got you
shame.
this far, so
Yeah. But I asked him, I don't care if I'm off the floor. I don't care what I have to do. Like I just want to work for you and just see the kind of stuff that y'all do, because he had gone over sort of how one of the accelerators works at that lab. And it just so happened that at that time there was something going on with like timesheets at A&M where people were kind of in a situation where they were either use your vacation time or lose it. So a bunch of people were all of a sudden using their vacation time, and he was kind of in a bind. So I think knee jerk at that time, my old boss was like, okay, well, I have this like really, excited, plucky kid who wants to mop my floors. So we're going to go ahead and hire her, and we'll teach her how to do this job. And what I didn't realize at the time was this was a job that was not open to anyone below like PhD level education. That has changed a little bit now, and I think that that was kind of as a result of this experimentation that my, old boss kind of did with my position. But prior to that, it was just PhDs. So I worked as an undergraduate beamline operator, which is a completely strange and new word, collection of words. But what I was doing was I was working at this accelerator and I was adjusting parameters on the beamline to produce a basically a radioactive like beam to deliver to customers for like electronics. So it's kind of a complicated concept to explain, but essentially what we're doing is we have these like metals or gases. So you'll have like an iron like atom, and what you're doing is you are trying to accelerate and ionize this particle so that it becomes like radioactive, and you're trying to produce ions that are very similar to the excited particles that you would see in space that would be hitting components and causing effects like single event effects or single event latch ups. And that's something I can talk a little bit more about later. But so I was essentially doing this like physics magic. And I had no idea what I was doing. I had no idea what I was talking about or like how any of this stuff worked. But my mentors at the time were awesome, and they kind of taught me almost like it was a trade, like how to do this. And I learned so much there. I mean, it was super hands-on, and I had a couple of really good mentors there. One of which named Bruce, who over one of the summers when we were on shutdown, him and I like rebuilt part of the beamline together. And he just like taught me a lot of like, I didn't know basically anything about like routine maintenance on any piece of equipment at that time. I mean, I look back now and I almost feel like I was a kid, but he taught me so much. And my old boss, Dr. Clark, he taught me so much and mentored me so much. And still to this day, I feel, like I can send him a text and, he would give me any advice that I needed. But through this job, it gave me sort of this insight into space environment effects. So I was about to graduate. I had been working this job for about 2 years. And I got this message on LinkedIn from who's now one of my current coworkers, basically saying there's this lab at Texas A&M and we're looking for people to work it. It's a little bit unconventional, but I would love for you to come out and, tour. It's kind of hard to understand the scope of everything until you, come and look at it. And at that time, I wasn't really sure what I wanted to do. I had some offers at NASA to come back, but my heart wasn't totally set on it. I wasn't sure that that's what I wanted to do. So I was having a lot of things going on in my life at the time. So I've kind of had this conversation with Sarah, but I just for context, I am an extremely faithful and very religious person. And I'd spent a lot of time at this point in my life just sort of praying over what I needed to do. And I had spent some time with the Lord and told him, I give everything up. I am, I know I'm about to go through a period of change in my life, and I trust you with that change. I need you to do all of it at once though, because I'm like super tired and I am not going to be able to handle it if you do it piece by piece, all of it together, all at the same time. And within the week, I had all of these job offers like rescinded from me. Like my boyfriend and I at the time like broke up. All of this stuff just sort of came down at once, and including this message that I got on LinkedIn from my current coworker asking me to come out and tour. And so just because I am a very faithful person and all of this stuff kind of happened like back to back, and it was all just so sudden and like knee jerk, I felt very compelled to go and like tour this lab and just see what they were about, because otherwise I would have not been interested whatsoever. So I went to tour. It was everything that I wanted to do. It was perfect. And it was going to be hands-on. I was going to be working with robotics because it was a robotics lab. And everybody was just so kind, and they were also offering pay that was substantially more than anything I had been offered with some of my other job offers. And I was just kind of dumbstruck at just how well this fit me. And so I ended up applying, and I did an interview, and it just so happened that they had one spot open. They needed somebody to do environmental testing for their equipment there for spaceflight. And here I am now. I work for this lab. It's called the Robotics and Automation Design Lab. And for all of the equipment that we plan to send to space, I space rate it, which includes vibration testing, radiation testing. Um, I I do thermal vacuum testing as well, and so I just work a lot with test setups and try and prove that our electronics can survive space conditions, LEO, lunar, that sort of thing.
And LEO stands for low Earth orbit, which, yeah, I don't know if we've mentioned that yet, but yes.
Yep.
Super cool. It's a super cool lab. I remember when I actually earlier this year, I got a little tour from you actually, and just the projects going on there are so, so, so cool. If you're able to talk more about them, or maybe even just what the lab does in general, if you don't want to delve into specifics,
Yeah,
I think it would be really cool to share.
so my boss is actually a professor at Texas A&M, and he's like the most unconventional professor ever. I mean, this lab, it's like 50% grad student, and then the other half is full-time engineers. And the projects have just gotten so big that it has required hiring full-time engineers to kind of push these projects forward. And I mean, I really think that what we're doing is like changing space robotics. There's only so much I can talk about. I don't know how many of the projects are really totally public. So I kind of err on the side of caution. But I know what's public on our website, and one of the projects that's really interesting is this. It's kind of like a rover project, but it's called 2-foot and 6-foot ball. One of the first projects that my boss, his name is Dr. Ambrose, did whenever he came to Texas A&M was to develop this mobility platform where it is a ball essentially with a pendulum in it that kind of acts like a rover. So it's a pressurized ball that in theory would be sent to the lunar surface, and a traditional rover would struggle to get to the bottom of a crater and come back. And obviously you don't want to send a person down to the bottom of a crater to maybe return samples. But this sort of rover, it would, it's a ball. You'd be able to throw it down into the bottom of the crater, and it could roll around down there and collect a sample, and could maybe send the sample back through a rocket kind of on the inside of this robot. Or it's just something like it could maybe do analysis on it and just transmit that back. But it's just a super interesting robot. Sarah, I think you saw it when you were there. It's the robot that has this like shaft on the inside of this pressurized like outside ball, and it's got a pendulum on the inside that swings back and forward and back, and uses the concept of like center of gravity to be able to roll forward, roll backwards, or be able to turn. And it's very, very interesting.
That's so, so cool. I mean, I don't know enough about the engineering specs of it, but like for pressurized rover, right? Like, are you able to talk more about what that material, like what that ball is made out of?
Yeah, so it's actually just like it's like a military bedliner. So like if you were to imagine like a military like HEMTT, or like some sort of just large like truck, or even I think some just like standard like on the highway type trucks, like their bedliner uses this like military grade spray. If I'm remembering correctly, because I don't actually work on that project, I think it's self-healing as well, like with heat. So I'm pretty sure like not necessarily bulletproof, but if you were to like shoot it, or like shrapnel was to go through the skin, I think the heat would end up repairing the hole as well. But we've done a lot of testing with it. We have something called the IPG, like where I work, so that's the Innovation Proving Grounds. We just have a bunch of like hills and bumps and rocks and various debris that we have out there that we use to test our robots. So if they are like mobile robots, we'll take them out there and we'll have them go through the course. And we've brought the 2-foot and the 6-foot ball out there multiple times. And I mean, and they do great. I mean, they can move super quickly. We have something out there called the Mayan Temple, and it's this huge concrete structure with different grades of like elevation on the ramps that go to the top of it. And we've made so many jokes about like putting the 6-foot ball up there and having it chase somebody down like Indiana Jones style. And like, of course, we've never done that. We have never done that, but it'd be funny.
It's so cool. Yeah. I mean, it's so hard to, at least from what I'm conceptualizing, it's so hard to make really anything, but especially like robotics that can function like that and put them in probably one of the most extreme environments that we know of, right? Like there are so many things that have to be up to par in order for that robot to function. And then also the testing, right? Like if we're using it on a different planet, but we still have to test that on Earth, right? So there's so much that goes into something like this.
Right.
I
Yeah.
just I just think it's really cool.
I mean, we have a couple of different projects that are mobile robots that we're working on. That one's the most public. If any of your listeners are interested and want to know a little bit more about some of the robots that we work on, if you just Google Texas A&M Rad Lab, RAD Lab, you can find our website, and you can see like pictures and videos. We even have a YouTube channel, but the only thing on the YouTube channel right now is videos of the 2-foot and the 6-foot ball. So and you can kind of get the scale. I mean, they're massive. I mean, the 6-foot ball is huge. The 2-foot ball is cute. It's little.
I looked it up right now, and yeah, huge.
Yeah, it is scary when they have it pressurized. It is,
and it floats.
Yeah. Oh yeah, it swims. Like it's so scary.
We'll put this in the description of the episode. Yeah, these pictures are really cool. Not what I pictured at all.
Yeah, no, it's so, and like I don't do it justice explaining it because it's so simple. It is just a pressurized ball, and on the inside there is a pendulum, and there's really not much else to say about it other than it's just a big pressurized ball. But through like the shaft that holds the pendulum in the middle, at least on the 6-foot ball, there's enough space for a payload. So, in that payload, you could have something like rocketry, so you could return samples, or you could have something that could collect samples like in soil. So there's just a lot of opportunity for it. So we have grad students that are working on this project in particular because there's a lot of room for research on it. But it's one of the more interesting projects in the lab, and I just think it's super cool. And I mean, visually, it's just like, I don't know. It's one of the things whenever I first toured, I was like, oh my gosh, this is like surreal.
And it's like kind of like you said, it's such a simple idea, yet that makes it so ingenious because like a circle, you have endless degrees of freedom. You can kind of take that anywhere. And what I'm wondering is like, could humans, I mean, maybe with like a sight hole or something, right? But I wonder if humans could utilize the same kind of model. I know we're still in like the early stages of this, so payloads, but could you stick humans inside the 6-foot ball?
Honestly, so my boss actually makes the joke that this is the size medium.
Okay.
So in theory, if we all kind of get our way, there will be a larger ball. And you probably could put somebody in there. I just don't know that it would be like an ideal ride.
Right.
I don't think that it would be great. But also I think maybe theoretically in a spacesuit it could be okay, but keep in mind that this is airtight. So even the hubcaps have to be airtight. You want to seal.
Yeah.
So I don't suspect that we will ever, I don't know, never say never, but I don't I don't think we will ever put somebody in the ball.
Yeah, well, if the ball, if the human is stuck to the rotation of the ball, right, then yes, I think that's a
Right.
lot to ask. But like if there was a way to put a human inside and just kind of have like the ball rotate around them and move, like that would be an interesting
I think
design
we could.
concept. Although very hard to pull off.
I think
Probably.
it would be interesting though. But keep in mind too that the hubcaps and
Yeah,
y'all,
right.
if any of your listeners go and like look, you'll see what I mean. There's these gold hubcaps on the side that are actually hard, and that whenever you open those up, you can kind of go directly into like the shaft of the pendulum. And keep in mind, I'm mentioning something that is like holding the pendulum. It's not the pendulum itself. That has to be like bolted down.
Mm.
So someone in theory maybe could be bolted into it. Um, I think that's kind of a one-way trip, but
Yeah. Um,
but yeah, they're super cool. I don't know if there's ever been a video posted of it, but the assembly of the 6 foot ball is just so like, oh my gosh. So they end up having to put this like giant like bed liner cover on its side. And then we use a crane to lift up the pendulum and put it inside. And it just kind of like whenever the pendulum usually lives on the outside of the ball. So 90% of the time what you're looking at is like the pendulum without you are looking at the robot. But the reason the robot can move obviously is because, the skin is around it and it's pressurized. But the pendulum itself is really what the robot is. That's all the moving parts. And whenever you start seeing it kind of get put together, the crane lifts it up and like puts it into its skin, and you slowly see like the ball pressurizing and everything. It's such a cool process to watch. I've seen it a couple of times. It's kind of a special occasion when we get 6 foot all pressurized because it's an orchestration, but I don't know, just super cool. I really hope there's got to be a time lapse out there somewhere because we've taken so many, but surely there's at least one on the website.
Emily, would love to hear about what your day-to-day looks like. Is it different every day? Is it, yeah, I just kind of, your career is just so different from mine. I really want to know like what it's like to like walk in your shoes for a day.
Yeah, so day to day for me is it's it's very different. It depends on like the season, right? So, um right now for me, I go into work, and I'll like sit down maybe at my email and I'll kind of check because I do a lot of collaboration with other people outside of the university. So, my lab is very big on collaboration, right? So we want to be good neighbors to other people who also want to work in robotics, and we kind of want to be a facet to like help other people. So usually you'll have somebody like email you questions about something or they want to use your equipment. So in my case in particular, because I do environmental testing, I have a thermal vacuum chamber. And so the thermal vacuum chamber goes from -60 to 120 degrees Celsius, and vacuum wise it can get down to like 1e -6 torr, which is incredible amounts of vacuum just for context. And I also have an oven and a freezer, so the freezer goes down to -86 degrees Celsius and the oven goes up to 260 degrees Celsius. So I also have a clean room. So before I started working at my job, the clean room was just a room.
And real quick, just I did the quick calculation. 260 degrees Celsius is 500 degrees Fahrenheit for our US listeners.
Yeah.
Um, a lot of the times when you're making food, your oven isn't even that hot. So that's a crazy temperature.
Right. Yeah. So sorry. I before I started working at this job, I never thought in Celsius. I always thought in Fahrenheit, right? Because I grew up in the US and everything, but for a lot of scientific purposes, they'll usually talk in Celsius. And so over the course of like the year that I've been working at this job, my brain has slowly morphed into Celsius. So whenever I think of like room temperature now, I think like, oh, it's like 23 degrees Celsius ish. And like, that kind of makes me want to throw up. I don't know why. It's just,
It objectively is the system that makes the most sense. It's
yeah,
freezing
I
is
don't know.
zero. Like it's very intuitive, so I don't blame you.
Yeah, that's fair. But I have a clean room. And when I first started working here, it was just a room. So I worked pretty hard. There's like class levels, so you can have like a class 1 to like a class 8 clean room. So we were kind of working towards having a class 7. I've gotten it closer to a class 5 now because it's kind of a smaller room and we don't use it super often. Um, but on the day to day, it could look like me being, upstairs at my desk, putting together test plans or, reading papers, trying to get more knowledgeable on, test practices. And then the other half of my job, and that's kind of what I'm doing right now, is I'm downstairs in my like test area and I'm trying to put together a test stand. I'm trying to figure out, logistically how I'm going to route like power or data from the outside of like my thermal vacuum chamber to the inside without breaking the vacuum. So that kind of looks like I have a pass-through plate on the back of the thermal vacuum chamber, and it's just got these connector ports on them. So, pins, and I pretty much just need to connect like power supply or like a relay, or right now I have like a Raspberry Pi, and I'm just trying to like create the right system and the right connectors to be able to plug into that pass-through plate and then plug the other side of the pass-through plate up to whatever equipment it is that's on the inside of the chamber, like just some sort of like electronic equipment usually that just needs to move or collect data. Um, or if I'm not doing that, I'm trying to like I use a lot of SolidWorks. I mean, not a lot. There are other people in my lab who use it a lot more than I do, but I'll use SolidWorks to kind of create like mounting structures to mount like pieces of hardware to like plates and things like for like a vibration test. I just recently had to design a mount that could hold our equipment in the X, Y, and Z direction because the way that, vibration testing works, you want to vibrate your piece of equipment in the X direction, the Y direction, and the Z direction to simulate launch loads. So what you're wanting to do is in one direction, which is generally like the Z direction, the launch loads will be a lot worse because it's like the Z direction, like up and down, right? So like for radiation testing, like I have to like develop I have to develop like the environment. If I'm not given like a specific like specification, I have to do a lot of like computer modeling to develop what the environment could look like. And there's a lot of like words that kind of go into that, right? Like fluence or flux. And that's just if anyone's familiar with like fluid dynamics, like people tend to use those words as well, just like particles per centimeters squared per second, or like having to figure out like what sort of components are the most susceptible to radiation, and are we expecting to see a certain amount of like effects as a result of that? How can we mitigate those radiation protection to mitigate some of these effects?
Quick question, actually. So it's interesting, right? On our show, we have a lot of different kinds of scientists. We've got folks that have come on who are hypothesis generating, hypothesis solving, folks working on papers, first folks working like in industry. What would you say, like, if you could summarize the goal of your work in a sentence, how would you describe it?
Right. If I could summarize it in one sentence, I would say the my goal is to learn. I think that's the simplest way I can put it. I am here to learn. So there's so much about this equipment that we don't know. And before you put it in in my equipment, like my thermal vacuum chamber, or put it in front of a beeline, you don't know how it's going to react. You don't know if it's going to survive or if it's not going to survive, or there's all these failure modes that can happen as a result of, some of this testing that you just don't know about yet. So sometimes I've had like coworkers ask me like, what's the point of this test? And the best way I can reply is, well, we don't know what the point of it is until it fails. Um, and
So it seems like hypothesis generating almost like you're working backwards, I guess. And I'm trying to put you excuse me, and it seems like I'm putting you in a box here, but that's kind of where I guess my mind is.
Right, and I think you're right. I think, and it can go both ways. It really depends. Like, and it's so annoying, like talking to engineers. Like, I know because, like, whenever you ask us a question, 99% of the time, like an engineer will say it depends. And I can get that that can be kind of infuriating, but so sometimes I will have somebody come to me and say, we think that because of the specifications that have been given to us, like whenever like we hypothesize that if it gets to this vacuum level, or it gets this cold, it's going to fail. And we just want to prove that. And I want you to run it through like thermal vacuum cycling and prove to us that like they're right or they're wrong. Or we have the hypothesis that their specifications like are way more strict than they should be, and we just want to prove that they're wrong.
That's so
So
interesting too, because like the way that it's funny because you're talking about how your objective is to learn about how these machines will function given, circumstances. At what point, and I guess this is a little hypothetical, but at what point is this technology ready for deployment, right? Like, because you can't necessarily, I imagine you can't learn everything, and there are some things you learn by trial and error. Is there like an industry threshold where it's like, hey, we've been testing this machinery for 5 years, it's ready to be deployed?
yeah, so in a way there is an answer to that question. So there
But it
are
depends.
Yeah, so it depends it depends a little bit. So NASA has come up with certain specifications for tests that hardware needs to go through before it's qualified for flight. So you have like proto-flight testing, and then you have qualification testing, and then you have acceptance testing. And there are certain levels that you need to meet in each kinds of testing to meet those standards. It also very much matters at what point in your buildup you are. So there's a certain type of testing you can do where you're doing component level testing. So like for example, you're like motor controller, and then like let's say like certain like subsystems in like a greater system, like you can test those individual things up to a specific standard, and then you can qualify those things and go through like you can go through qualification testing. So you qualification testing tends to be like 1.25 times more intense than like the actual expected conditions, so you're like over stressing it, so and giving yourself a little bit of leeway to be able to say like, okay, this isn't just going to like squeak by, like this is really going to survive. And then you take that same like flight hardware and then you put it through like acceptance testing, which is like exactly like the conditions that you could expect. And then you say, okay, it's been through qualification and acceptance testing, we've proven that it can survive in this environment. And so we can qualify and put a big old check mark on like this specific subsystem or this specific component. There are some organizations in NASA who will do full like hardware level testing of the entire system. So like for example, like rest in peace, but Viper. From my understanding, Viper did a full thermal vacuum test of the entire rover and did like a full like vibe test of the entire rover. Um, and if you have the means to do that, like by all means do it. But for like smaller labs, the best and most cost effective thing for you to do is to do like component level testing, which can be just as effective, but it takes a little bit longer because you're having to take every tiny little piece or like chunks of pieces from this system, and you're having to test them individually instead of as a full unit. But in a way, it can be more robust because it's easier for you to identify what went wrong when you have these smaller components that you're testing.
That's really helpful. Yeah, yeah, really interesting stuff.
I also want to ask real quick because I know we've talked about it before, but I want to nerd out a little bit on space radiation. Because like
Yes.
in from my angle, right, I see it from more of the human risk perspective. But I think what people, at least in my field, sort of, I wouldn't say fail to recognize, but it's not the first thing that we jump to, is how radiation can affect robotics and electronics and payloads and inanimate objects, right? There's a real impact on that. So when you're engineering anything for space, that's something you have to keep in mind. So, yeah, I mean, I'll let you start the conversation because you are much more knowledgeable on this than I am. Um,
Yeah, and honestly, like I can also be super nerdy about it too. This is honestly my more like favorite part of my job. It's harder to do just because it's so expensive. But radiation testing is something that you really need to do because, outer space is extremely like radioactive. There's particles flying around everywhere. There's like little protons that will like fly through, which are just like the smaller like subatomic particles, but you also have like ions. Like you'll have full ions of like iron or nitrogen or helium, and those are considered like heavy ions. They can hit your components and like really harm them. But to explain this, it's kind of important for you to have a little bit of context of like how our electronics work. So everyone kind of understands the concepts of like ones and zeros, right? Like bits. But the way that all of our electronics work on like a fundamental level is they're essentially just reading like yeses and nos. So like a yes or like a one usually denotes like there is like electricity like passing through a circuit. So yes. Or you'll have like no electricity passing through a circuit, and that's like a zero. That's a no. So we have essentially created like circuits and like components that are running on such little power that the energy in a particle that passes through one of those circuits could be the equivalent to the power that equals a yes in a circuit, if that makes sense. So you could have a very, very important set of like logic gates. So keep in mind when I say that like these pieces of equipment are built on yeses and nos, they're built on a series of logic gates that are a series of yeses and nos that eventually lead to, you know, a set of conditions that make something happen inside like a component. So you could have a particle hit at just the right time and impart just the right amount of energy to cause the right amounts of yeses and nos to flip to a yes that it wasn't before, or a no it wasn't before, and make the component do something crazy that we weren't expecting. So it could cause something to turn on when it's not supposed to, or turn off when it's not supposed to, or it could I don't know, it could start reading data that it's not supposed to be reading, or like if it's a motor, it can start like commutating incorrectly. And so these are just all things that are common in space. So like for example, in low Earth orbit, there's a lot of protons, and protons don't normally cause single event effects. However, because there's so many of them, there's like and if I'm remembering this number correctly, there's like a 1e to the 5 chance that a proton will cause a single event effect, because it will hit another like ion. It will like dislodge an ion in the material that it's hitting. So like for example, like if you have a casing around something, you'll have a proton that will hit the casing and dislodge one of those ions and cause a heavy ion to hit, which does have the right amount of electricity to cause this effect. Or you could just have actual heavy ions that are just so energized that they will pass through any covering that you have or any protection you have, and they'll hit your component and they'll just fry it. And so those sort of things, the protons generally come from the sun, and they're trapped around the Earth in something called like the Van Allen belt. So there's just these very proton-rich zones around the Earth. And then you have something called GCR, which is galactic cosmic rays, which are a lot of these heavy ions that are coming from outside of the solar system. So you have these heavy particles that are coming in, and ironically, GCR is a lot worse when the sun is at a solar minimum, because the solar winds push GCR out of the solar system. So whenever you have, the sun at like a solar maximum, it's generally pushing a lot of that GCR out. So it's just all very interesting. Like I've been kind of rambling here for a couple of minutes, but I'll let you guys ask any questions. But this is like, I love it.
So I think all of that is really, really cool. I think it's also especially interesting to like that the solar minimum is actually the most harmful time, right? Because you'd think like, oh, solar radiation, like there'd be more in a solar maximum, but that's not the case.
Yeah.
And just how much certain ions can harm those components is it's I feel like I'm still wrapping my own brain around it. And like I'm still wrapping my own brain around the human risk side of it. So like to kind of see it from this angle is also, I mean, there a lot of elements overlap, but it's mind-boggling to think about.
Yeah, so there's actually there's a chart you can look up online that shows um each ion how much energy it imparts on a material as it's passing through it. So there are certain ions that are a lot more harmful because they're really imparting a lot of energy as they're passing through, which makes them so harmful. Because so here's just an example. There are so there's something called an LET. So it's called linear energy transfer. So that's kind of going back to what I was talking about, like how much energy you're imparting on a material as you're passing through. So um you can have a proton that is a really, really high like LET value, but it's not really imparting a lot of energy in you as it's passing through. So generally when you're going through cancer treatments, you'll have a like proton beam that's somewhat closer to like 200 MeV. So MeV is just, I mean, don't let that word scare you. It's just like an energy unit. It's a mega electron volt. That's just the word that we use to describe how much energy a particle has. But if you were hit with like a 45 MeV, that beam, that could be like a lot more harmful for you because it's not going as far in your body and it's also imparting a lot of energy as it's doing so. Um, but then for like, it's a little bit different when you're talking about like ions because the MEV or like the LET that's like associated with like that ion is talking about like the energy of like all the little particles that are like in the ion as well. And also like the like energy that it's like putting in your body as it, or not necessarily in your body, but in a material as it's like passing through can kind of change like ion to ion as well. So like for example, one of the most dangerous beams that you can put your electronics in front of, there's two, but one of the more common ones that's really dangerous is iron. Iron will mess you up in space bad. But the beam that people generally test at when they're doing like heavy ion testing is gold. And it's considered like the gold standard of radiation testing because if you can survive that, you can survive anything. Which is ironic. I think that's kind of funny how that works out.
Why not test with iron? Because you said
Um,
it messes you up, which yeah, I'm curious.
yeah, because gold is worse. So if you're gonna do like an encompassing, so if you're gonna be testing like at like the level where you're trying to see if like iron will hurt you, like you're generally going to want to try and protect yourself for like everything anyways. So why not just kind of go the extra step and like test for gold is kind of my mentality.
Okay,
Um,
so gold will mess you up more than iron.
right. So
Oh,
yeah,
okay.
I that's kind of my understanding. If somebody is out there listening right now and for whatever reason you know more than I do, I'm sorry for misrepresenting that, but that is my understanding right now that gold is worse and that if you're going to be testing like at that level, you might as well just go all the way and just test for gold.
That makes sense.
Well, this has been a fascinating conversation. I really appreciate you taking the time to like come on our show. Any like closing thoughts or like anything you want to leave our audience with?
Yeah, so if I could impart any wisdom on anyone who is listening right now, I would just say that your life is not going to go the way that you expect it to go. I did not think that I was going to do environmental testing for my career. I've kind of set myself up at this point where this is likely going to be my career. I mean, obviously, I could be wrong, But whenever I was a kid and I was just thinking about where I wanted to go, this is just not at all what I thought I wanted to do. And I've kind of said this sentiment to Sarah in the past, and I've made this sentiment several times to some of my closer friends, but everything in my life that I ever wanted badly, I did not get. It was not given to me. Nothing in my life went right. Everything went in quote unquote wrong. But I am so incredibly happy and I have everything that I need. Everything that, like, if I received everything that I wanted in my life, I'd be so miserable. Horrible. I would be so miserable. I think to that life and I just think of a sad, sad life because I have the knowledge now to know that, even though that's what I wanted, it's not what I needed. However, the reason why I'm happy today is because I was willing to recognize that and understand that I have in my life received the things that I needed. And it's kind of a perspective change. And I think that's a mentality that people really need to have where it's kind of go with the flow. Um, just as a very, very brief story, I wanted to be an aerospace engineer so badly. And people don't realize that Texas A&M has something called an ETAM process where you have to apply for your specific major once you get in. So you apply to be an engineer. And then once you're in, you apply to be a specific type of engineer. And I missed the GPA, like automatic acceptance GPA limit by like 0.1. I was super close, but like it just didn't work out.
Wow.
Yeah. And I think that it was like a 3.5 and I think I had a like 3.4. And if I had gotten into aerospace, I don't think I'd be where I am today. And I don't think I would have enjoyed it as much. I think there's a lot of things associated with that major that, like, now looking back and having friends who were aerospace engineers, I don't think it's exactly what I thought it was going to be. But I also would not have met Dr. Curry Gregg. Like, I probably wouldn't have worked at the cyclotron. And I look back on all of these things that I wanted to do, and I just am filled with this immense sense of like gratitude that I didn't get to do them.
What a positive outlook. And I think another thing that you've taught us indirectly is network, 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 and be yourself. And if you're a nerd about something and you want something, go get it and go try. I think that that's another really valuable lesson that, your journey has left us with.
Yeah, I mean, and just, say what's on your mind, obviously.
Yeah.
Yeah, no, it's such a good lesson. Like, you could want so much, but what is it that you really need? And like you said, life has its own way of working things out. So,
Right. I
yeah.
mean, you just have to just be grateful for the things that you have and make the most of every opportunity that you have. And, you can say what you want about luck. Oh, I'm so lucky. I've had all these lucky things happen, right place, right time. But at the end of the day, if you're not willing to put yourself out there and take advantage of nothing, you know what I mean? People do make something out of nothing. And that really just comes down to, do you have the right mentality at the right time?
Mm-hmm. Wise, wise words.
Well, thank you again for joining. Really appreciate it. This has been a great conversation. And listeners, thank you for returning for, I think this is what, our third season, third year. So it's really exciting stuff. So thanks for sticking with us and for listening to Emily's story. You can find us on Twitter, and now we get to the part of the show where I forget our social handles. I believe on Instagram we are interactome_media, and on Twitter we are at the Interactome. I do believe I'm right this time. Sarah's giving me a thumbs up, so I think I'm in the clear. But yeah, thanks so much for tuning in, and we'll see you guys next time.